Have you already read it? Oh, no, everyone's it's all good. Like versatilism.
Christina, why did she ask us to pick like 3 random
At least second period.
I'm scared.
Like, you know, that bird was like broken bones like fall down. Oh, yeah. Yeah, why is he doing that? Okay,
Okay, guys, we're starting a new unit today, polar coordinates. There's definitely some things that are uniquely different about polar coordinates versus standard coordinates that we see with Accel. But I think you're also going to see a lot of similarities from last unit with component form and radius and theta. We're gonna see a lot of connection between this and the previous unit as well. Okay, so here's the calendar for this week or for these next couple of weeks. Today we're just learning how to plot points on the coordinate plane, on the polar coordinate plane, and then tomorrow going from rectangular to polar. I think you'll see a lot of nice connection between this and the previous unit. Next week, no school Monday or Tuesday. And then we'll have a review day on Wednesday, and then just a short quiz on Thursday, just going over what we covered today and tomorrow. We'll cover a few more topics. We'll have a short check-in quiz Tuesday, and then we'll have a test the following week into March. Okay, so two quizzes before our test. Okay, I'm skipping the Desmos activity at the beginning. I just want to kind of go directly into notes. So we're halfway down the first page, or the second page here. Oh, and by the way, the back of your calendar, you're going to see a lot of helpful, useful summaries. So keep this handy when you're doing homework, and it's always good to review with all the formulas on the back page. Okay, so halfway here, halfway down the page, there's more than one way to plot a point. Now, rectangular graph, there's only one way to plot a point. So let's just start with something that we recognize here. Let's say there's point A located at order pair 3, 4. So what you would do is on the coordinate plane, you would go 3 units to the right, up 4 units, plot that point, call it point A. However, we could potentially, so let me mark that X and Y. But we could also reach that same point if we know the theta, the angle measure, and the hypotenuse. So here, let's say I have theta, and right, if I know what angle I'm supposed to be at, and if I know how long I should be going out along that hypotenuse, I can also reach that same point. Okay. So that's really the basis of polar graph, is rather than using left and right, we're using the radius or hypotenuse and theta. So r is the radius. But technically, it's the hypotenuse of a right triangle. Theta is the angle. So the previous unit we called that magnitude, right? So magnitude, same idea, right? We want to solve for r. I'll just do Pythagorean theorem. We want to solve for theta. I'll just use inverse tangent. So a lot of same carryover from last unit. But a polar graph is going to look a little different. It's going to be along a circle with these concentric circles. That's going to tell us what how many units we are away from the origin. So here's an example where rather than giving you x and y left and right, they're giving you the radius and they're giving you the angle. Now it feels a little bit backwards because we're really not going to know how far to walk out until we know what angle we're dealing with. So just be aware that it's the r that comes first, then the theta, even though theta feels like that's the first thing you want to look at. So, but we do want to look at the 135 degrees first. Okay, which quadrant is that in? Second, right? What's the reference angle for 135? 45, right? So you know it's going to be the middle angle in the second quadrant. So go ahead and mark 135 degrees. Now you're going to put your pen or pencil at the origin, and you know that you're going to be walking along this line here, either towards or away, depending on whether that number is a positive or negative. So if it's a positive 2, like in this instance, you're going to be walking towards the 135 degree line. If it was negative 2, then you'll be walking away from it, but you're still going along that line. You end up in the fourth quadrant. But here, the concentric circles will tell you how far to walk out. So you're going to walk towards 135, 2 units out, so 1, 2. Okay. Next up, point B, 7 pi over 6. Which quadrant is that in? Third, right? This is more than pi, so 7 pi over 6. You know it's going to be closest to the x-axis, third quadrant, because that numerator is more than my denominator. Okay. Put your pen or pencil directly at the origin. Are we walking towards or away 7 pi over 6? Towards, because it's positive 1. Yep.
It's like it's like a unit circle. It's kind of
Yeah,
like-
pretty much. Yeah, yeah. Think about it as a unit circle, but now, now we have magnitude. We know how far to walk along. Yeah, walk out along that unit circle. Okay, page 3. Oh, sorry. I meant for you guys to write this down as well. So right here. So when you see a positive theta, either radians or degrees, you're going counterclockwise, right? And we know that, right? We're doing the 30 degrees, 60 degrees, 120 degrees. We know to go counterclockwise. Negative theta, you're going to go clockwise. But you can always counter negative theta by adding 360, right? If you add 360, you can always create a version of that theta that may be easier to work with. And then we talked briefly about this as well. Positive r means that you're walking towards that theta angle. Negative r means that you're going into another quadrant. And you're walking opposite that direction. Yes, yeah, you can add 360. Or if the theta is too large, you can subtract 360. But same idea here. Now theta can be either given in radians or degrees. If it's a negative radian, you can always add 2 pi. If your radius is too large, you can keep subtracting 2 pi. Okay, everybody good? Okay, next page. So it says name the location E in 4 different ways. So we can give different combinations of theta or negative theta in terms of radians or degrees and in terms of positive. So we can reach that point E a number of different ways. Let's start with the most obvious one. Okay. So in terms of radians or degrees, which angle is that E located in? Yep. And in terms of degrees, it's going to be, oh, sorry, it says, in terms of pi. So we're going to leave everything from the radians. Okay, so here they're specifying. Okay, so 7 pi over 6, that's good. Your order pair is going to be R followed by theta. So let's give one version of it. So obviously the easiest is 7 pi over 6. Sorry, that's my theta. How many units am I walking out from the origin? 3. Okay. Now let's look on the other side of it. What angle is related to that if I'm following that line into the first quadrant? 5 over 6. Okay, so let me just notate that because we can create something in terms of 5 over 6 as well. So to get to point E, I can also say pi over 6, but instead of walking towards pi over 6, I can walk what? Yeah, walk away. So if I want to walk away from pi over 6 and reach point E, I would do what? -3. Does that make sense? I'm still hitting point E because imagine if I had pi over 6 being my theta, rather than walking towards pi over 6, I'm going to walk away from it. I'm going to walk backwards. I'm still ending up with point E. Okay, are you guys okay with that? Okay. Now let's create a different version of this theta by subtracting 2 pi.
Would it be like -3 since you went away from 7 pi to 6?
So I want to reach this same point E. Right, so if I'm looking at that second order pair, I would say, oh, pi over 6, that's great, first quadrant. If I'm walking away from it, I'm going to end up in the third quadrant. So if I want to create a different version of 7 pi over 6, I can add or subtract 2 pi. Let's just say I want to subtract 2 pi here. Oh, I got to subtract 2 pi because I have to land in that region between -2 pi and 2 pi. So if I subtract 2 pi, same thing as 12 pi over 6. What's another version of 7 pi over 6? What's 7 minus 12? Negative, yeah, -5 pi over 6. So -5 pi over 6 is the same location as 7 pi over 6. So that's a third option I can give. So -5 pi over 6 is going to land me in that third quadrant. I'm going to walk 3 units towards it. It's the same as 1. It's just I'm giving a different way of getting to that third quadrant. Now let's create a different version of pi over 6, right? We said that we could always, to add or subtract 2 pi, to get the same angle. So what's pi over 6 minus 12 pi over 6? Negative 1.
Negative 1 pi over
Yeah.
six.
That's the same thing as pi over 6. It's just that we're adding and subtracting 2 pi, creating a different version of that angle, a coterminal version of that angle. So first quadrant, negative 11 pi over 6. Sorry. So if I know that negative 11 pi over 6 is in the first quadrant and I want to walk towards with E, I gotta go where? I gotta go -3, right? So all these will take me to the same point. Okay, any questions there? So that's all we're working on today. We're just getting that practice, seeing if we can create different versions of naming the same point. Okay, so for the next example, I want you to do the same thing. Plot 3 points. Okay, so let me give, let's have this be between -360 and 360. So this one, let's practice using degrees. And I'll give one version and you guys try to find 3 other versions, okay? Sorry, point A. Yeah, let's just do 1 point. Let's just figure out the same thing as before. Plot this point and see if we can get to that same point using 3 other variations.
All in degree mode.
Yeah, everything in degree mode, yep, for this one.
Minus 135.
Yeah, you want to do 135 minus 360 because you're starting at this location and you're going backwards 360. If I do 360 minus 135, that's a different thing. I'm going. So you know that you're going to get 2 positive measures and 2 negative measures, right? So those are the 4 variations that we can create that's going to land us between negative 360 and 360 and all hitting the same point. You're either walking towards the second quadrant or you're walking away from the fourth quadrant. Okay, so your classwork is page 4. And we're going to skip 13. So just do the top 1 through 11 and then 15 through 21, but you can skip 13. And I'll work alongside as you guys are trying these problems as well. Again, skip the word problems and you skip 13.
Yeah, that's good. It's growing.
Okay, does anybody still need this page? Yes, thank you.
What does it look like?
Um, sorry, which problem? Oh, this is F. You can do any variation, yeah, but you can do variations of this or. Okay, everybody good, 1 through 11?
We can't, there's like nothing way that we can learn about. This is something.
Oh, yeah, sorry for the bottom third of the 15 through 21, if they start you with degrees, then give 3 names using degrees. Okay. If they start you with radians, then give 3 names using radians. That's fine.
What's the city, 300 VFLs. 800.
I'm trying to figure out what our stuff. You know, what is stuff.
So I think. It's a lot of water.
Give different versions.
So that was a there.
Come back here on last year. That one, I mean, I can try to. Yeah, that would be for our. That's natural. That's natural. This is fun. You don't need to. No, no, so you don't have it. That's one of the. So you say, I need more than this. Yeah. Yeah, I'm sorry.